Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter SHM, or we can tell oscillations, and SHM means simple harmonic motion. Actually what happens, oscillation is so many types, but SHM is one of the simplest harmonic motion. Okay, so from there only we are going to see the question. And which kind of oscillation? Two kinds of oscillation is there. One is the what we tell undamped oscillation, one is a damped oscillation. So in absence of friction, nothing is mentioned, means in absence of friction, which one I told undamped oscillation. So see here, a particle is executing simple harmonic motion with a time period 2 seconds, okay, and amplitude 1 centimeter. Now if capital D and small d are the total distance and displacement covered by the particle in how much? 12.5 seconds. Then this capital D by small d value is how much? Okay, students, so first let me write here the data. Time period how much given here? If I will write here, students, see this time period is given here 2 seconds. After that, amplitude, as I have told you, undamped oscillation. So in undamped oscillation, amplitude always remains constant. That means maximum displacement from mean position to the extreme position. After that, the total time how much given here? Total time in 12.5 seconds. So this total time is given here. How much is there? 12.5 seconds. And what we have to calculate? We have to calculate this capital D by small d, that means distance to displacement ratio. Okay. So students, before going into this question, please remember that one thing. In case of oscillation, what happens that here, if I will draw here, so see here, this is O, I have taken this P, and this I have taken Q. Okay. So what used to be happen that here, let's take, I have taken here mean position. Okay, mean position, and here let's take time measurement started from here at t equal to 0. And when the time measurement t equal to 0 starts from the mean position and particle is going in this direction, we use the formula x equal to a sin omega t. Now all these basics and all, but okay, here we don't need it here. So what will happen that here in this situation, this is the mean position, and anyhow this is the extreme position, and this is also extreme position. So what will happen that when the particle will complete one oscillation, that means where to where? O to P, P to O, O to Q, Q to O. Then this is called what? This is called one oscillation here. Okay, so see if I draw here like this here. Is it like this? Means it will happen like this here only, but see here I am drawing like this here. Like this. Okay, and if I write here the values, so what will happen that here? T equal to 0. Okay, and in the question what they have given here? 2 seconds. 2 seconds. That means T equal to 0 here, and here how much is there? T equal to 2 seconds. Then can you tell very well? This 2 seconds is going to divide into the how many parts? 4 parts, is it? So we can write here, here it will be how much here? 0.25 second. Here we can tell how much is there. Students, correct? T equal to 2 seconds, na? So 0.5 actually, not 2.5 actually, is it? Now correct. 0.5. Here to here, 0.5. Here to here, 0.5. That means it will become here what? T equal to 1. Then here it will become here what? T equal to 1.5, and then it will come here T equal to 2 seconds. Is it? I hope so. Very clear, na? That is the basic, na? So see here, total how much? Time period 2 seconds. So 0 to 0.5, 0.5 to 1, 1 to 1.5, 1.5 to 2. Is it? This is the one oscillation. Okay. Now after that, to calculate displacement means directly we can tell, but for the distance we should know how many oscillations are there. Okay. So students, we know that very well here. To calculate the number of oscillations, it is given here T equal to NT. T is the total time, N is the number of oscillations, and capital T is the time period. Okay. So we can tell very well the number of oscillations is given here T by capital T. T how much given here? See, 12.5, and capital T how much given here? 2. Is it, students? So 12.5 by 2, we can tell very easily it is going to be how much here? 6.25. Or we can tell, see, now we have to be little bit, 6 plus 0.25 number of oscillations. Is it? Or we can tell here 6 plus anyhow 1 by 4. 6 plus 1 by 4. So students, here if we go in a somewhat detail, so what will happen that here, if I write here the distance here, okay, see the distance. How many oscillations? 6 oscillations. 6 oscillations means you know very well. In one oscillation, how much distance it will travel, you know very well. If this is the, for example, if this is x equal to 0, so amplitude I am writing here, x equal to plus a, and here x equal to minus a. So in case of distance, what will happen? See, a this side, a, again a this side, total 2a, again a this side, total 3a, again a this side, total 4a. That means in one oscillation the total distance will be how much? 4a. But here how many oscillations are there? You can see very well 6 plus 1 by 4, or we can tell 6.25 number of oscillations. So if I write here 6.25, is it? And in one oscillation, how much distance it is traveling? 4a. And here a, how much here? 1 centimeter. That means we can write here total 4. So students, when you will multiply this 6.25 into 4, because in one oscillation again how much here? 4 centimeter. So what this will come here? This will come here after multiplication 25 centimeter. This is the distance. After that, students, if I talk about here the displacement. So anyhow, after 6 complete oscillation, now again 6 complete oscillation, again the particle will come here, and after that what will happen that here? Okay, so students, here we can tell here again this one will go how much here? 0.25, is it correct? So see here please, 12.5 by 2, 12.5 by 2, anyhow 6.25. so 6 and 1 by 4 oscillation. Now 1 by 4 oscillation means it is not a second, 1 by 4 oscillation. So here from here to here 1 by 4 oscillation, is it? That means what will happen that here? 6 and 1 by 4. Okay, that means again the particle will be somewhere here only. Now after the 6th oscillation also the particle will be somewhere here only. That means displacement how much is there? This will be 1 centimeter. So students, if you take the ratio like 25 centimeter by 1 centimeter, what is going to be the option here? The option is going to be here option B, is it? You can see here very well. Okay, so again I am telling you, in a 12.5 second what is happening? The particle is completing 6 and 1 by 4 oscillation. So 6 means complete, is it? And one more 1 by 4. So after completing 6 oscillations, again it will reach here, and to complete 1 by 4 oscillation, it will go from O to P. And in this situation, you know, displacement means what to tell, the shortest distance between initial and final position. So only this displacement is going to be how much here? 1 centimeter, is it? Then we have just divided it and we have got here answer 25. Is it, students? So I hope so you have understood very well. Keep studying, keep growing.